Hello sports fans, Mr. VB here to tell you all about writing a net ionic equation. Let's get started. Suppose we are told we have aqueous lead-2 nitrate mixed with aqueous sodium chloride and we're asked to write the net ionic equation. Well, here's how we start. We have to look at what we've got. Lead nitrate, lead-2 nitrate. So lead is Pb and nitrate is NO3. Nitrate takes a -1 charge, and we're told that lead takes a +2 charge. So we already know we're going to need 2 of these nitrate anions to balance out with a lead +2 cation. And of course, that's given us as aqueous. So we've already written the first compound in our skeleton equation. Plus aqueous sodium chloride. Well, we're familiar with that. NaCl, aqueous. And we want to know, what's that going to give us? Well, the lead is a cation, and the sodium is a cation, and the cations will try to trade places. So, tentatively, we think we're going to get lead chloride and sodium nitrate. So let's write that out. Lead 2 chloride. Since lead has a +2, chloride has a -1, we'll need 2 chlorides plus sodium nitrate. Nitrate has a -1 charge. Sodium has a +1 charge, so that's a neutral compound right there. And all nitrates, by the way, are soluble. So let's put aqueous there. We're not really sure about lead chloride, so we could refer to that table in the textbook that says all chlorides are soluble except silver, lead, and mercury. And there it is, lead. So we know that is a solid. It is not soluble in water. So that would be what I would call the skeleton equation. Now let's look at the coefficients and see if we need, well, let's see if we need to add coefficients in order to balance this. Well, I have 1 lead on the left side and 1 lead on the right side. So far, so good. I have 2 nitrates on the left and only 1 nitrate on the right. So let me use a color here and say, well, I think I need 2 of these to give me these 2 nitrates. So let's try a 2 there. Let's look at sodiums. Okay, I have 1 sodium there and 2 sodiums there. So it looks like we might need to have 2 sodiums there. And let's go back and check everything out. 2 nitrates, 2 nitrates, 1 lead, 1 lead, 2 sodiums, 2 sodiums, 2 chlorides, 2 chlorides. So now we've gone from a skeleton equation to a balanced chemical equation. But we're asked to find the net ionic equation. So that means we have to take the balanced chemical equation and show all of the aqueous components as their respective ions. So let's go from this. I'll switch colors. Let's go from this balanced chemical equation to a complete ionic equation. Well, lead will be an ion, as will nitrate, so we could write, except the pen doesn't work, let's try the other side. We could write that lead 2 plus aqueous plus 2 of these nitrates also aqueous plus 2 sodiums also aqueous plus 2 chlorides also aqueous, will give us lead chloride. Well, that's a solid, so it's not aqueous. So it will be a precipitate. So we don't want to break it up into its ions because it will not be aqueous. So we'll just write that as lead chloride solid plus, now we have 2 sodium ions, aqueous, plus 2 nitrate ions, also aqueous. So we've gone from a balanced chemical equation to a complete ionic equation. Now let's figure out what our spectator ions are. Well, on the left I have lead 2+, and on the right I do not have lead 2+, so I can't call that a spectator ion. I have 2 nitrates on the left. That should actually have a negative charge there and there. 2 nitrate ions, polyatomic ions on the left, and 2 nitrate polyatomic ions on the right. Polyatomic ions simply means the N, O, and the 3 together make up a single ion. So those are on the left and on the right. So I will call that a spectator ion, and I'll cross it off. When I cross it off, doesn't mean it's not important. It just means it's not ultimately what's going to give me the precipitate. We have sodium ions on the left, sodium ions on the right. We can cross those off as spectator ions. And I think that's all the ions here. Yeah, the chloride ions are on the left, but on the right-hand side they exist as part of lead chloride, which is not, so the chloride here will not be an ion. So let's take this mess that we've generated and come up with the net ionic equation. The net ionic equation would just be rewriting everything that's not crossed out. So we would have lead ions with a charge of 2+, and they are aqueous, plus 2 chloride ions, also aqueous, giving us lead chloride, or I should say lead 2 chloride. Remember, lead can take on either a +2 or a +4 charge. So this is lead 2 chloride, PbCl2, which is a solid. So there it is, the completed net ionic equation. Now let's verify that it's balanced. We have 1 lead on the left, 1 lead on the right, 2 chlorides on the left, 2 chlorines on the right. Charge-wise, we have to look at charges. We have a +2 charge here, a -2 charge here, so we've got a +2 ion and 2 -1 ions, so that's essentially a +2, -2. Well, those cancel to give us a net charge of 0 on the left, and there's no net charge on this precipitate. So there it is, a completely balanced, atom-wise and charge-wise, net ionic equation for the original reaction of aqueous lead 2 nitrate mixed with aqueous sodium chloride. You can see that the net ionic equation really tells me what components go into making the precipitate. I'm Mr. VB. Thank you for watching.